Hey football fans, I'm Cynthia Freeland and welcome to the NFL's 4th annual Big Data Bowl powered by AWS. Our next team of finalists are graduate students at Simon Fraser University in Vancouver, Canada, who developed a framework for identifying and comparing the best punt returners in the NFL. Say hello to Robin, Brendan, Riker, and Elijah.
Our team is Robin Ritchie, Riker Morrow, Brendan Kumagai, and Elijah Kavan. We are a group of graduate students at Simon Fraser University in Vancouver, Canada. Our Big Data Bowl entry is punt returns, using the math to find the path, where we look to improve a punt returner's ability to gain yards on a play. Today, we have chosen to show how our work can help the Kansas City Chiefs elevate their punt return performance through a mixture of video review, data visualization, and novel metrics. In 2018, the Chiefs ranked 3rd in average yards per return, but dropped to 26th in 2020. We will focus on Mecole Hardman and his role as the lead punt returner in both 2019 and 2020. Hardman has all the physical tools to be a top punt returner in the NFL. So what has caused the Chiefs punt return unit to struggle in recent years? To motivate, here is a clip from the 2020 Week 12 matchup between the Chiefs and Buccaneers. Hardman completes a 5-yard return, attempting to stretch the field by breaking contain with his speed. We will dive deeper into this play by showing what Hardman may have missed and evaluate his decision-making over the course of the return.
Our goal is to determine the optimal route to the end zone. We look to find gaps that the returner can exploit by quantifying field pressure using a metric for the penalized expected arrival times of the opponents. To do this, we make thousands of calculations at every frame. Finally, we adapt the A-star algorithm, which connects the dots between the actionable gaps and finds the path that would help the returner gain as many yards as possible. Once we have this optimal path, we use a metric called the Prochet path deviation to quantify the difference between the optimal and observed paths. This is used to evaluate the punt returner's decision-making, and next will be used as a novel metric in our conditional density model, which predicts the expected yards remaining on the play. This metric, along with blocker leverages and convex hulls that quantify field control, are among the key inputs in our model, which associates a probability to each potential ending yard line. We then use this distribution from our model to evaluate returns through our final metric called the return yards above expected, or RYAE. These methods allow us to quantify both how successful a return was and the reason behind this success.
Back to our original clip. Let's see how Hardman performed compared to our optimal path. At the moment Hardman receives the punt, he is standing on the 5-yard line. Given the current situation, our model predicts Hardman will make a 15-yard return. Notice that in this moment, Hardman has 3 well-positioned blocks in front of him, as well as a 4th blocker that's set up to seal the gap. Our algorithm takes these into account to find the safest path through the kick team's coverage. Throughout the play, Hardman disregards all gaps and blocks, moving laterally in hopes he can feed his opponents to the outside. In the end, Hardman gains 5 yards with an initial expectation of 15. Averaged over the play, he achieved 9 yards below our estimate.
Let's move on to a more broad overview of the 2020 season and see how Hardman compares to our other star punt returners. Our model places Hardman at 15th, well behind players like Olszewski, Harrison, and Renfro. Notice that Hardman is the only player here with a negative RYAE per play, and furthermore he is only achieving about 25% of his expected yards. Here's a graph comparing yards gained per play with the average path deviation. Based on our results, Hardman can improve his yards gained per play by better considering his available options. Improving his ability to find gaps and blocks available will help to bring him closer to these other key returners. Placing these 4 punt returners' paths on the same starting line, Hardman uses his speed to stretch the field laterally compared to other stars who tend to return more vertically. Although his paths tend to avoid heavy contact, it's unlikely this strategy will result in a successful return. Now let's contrast our optimal path with Hardman's observed path. On the left are returns where Hardman's path deviations are the largest, and his returns are well below our expectations. Compare these to the plays on the right, where his path deviation is small. Here he uses his blocks to increase his upfield movement, completing a near perfect return according to our model.
The Chiefs special teams coordinator reiterated this when he spoke of Hardman's performance after a recent playoff win. He stated that he ran tough, he didn't run out of bounds, he actually cut back into the field, noting that he had his best punt return day since he's been with the Chiefs. This is quite different from Hardman's typical strategy, and we believe that our tools can be used to ensure he has more games similar to this one. Consequently, this will improve the Chiefs' field positioning and lead to more points on that board. Thank you for your time.